cruising in my lane fast, call it high speed. I've been working hard, yeah, I've been working nightly. If you think you'll win, ha, not fucking likely. I be taking shots, yeah, cold-blooded, icy. Watching numbers grow is what I call sightseeing. In the front row.
Hello, and here we are again for another project. This is Obstacle Avoiding Robot using Arduino Uno and HC-SR04. Do not fast forward this tutorial so that you do not miss any necessary connections, polarity, instructions, and especially the procedure of downloading libraries and uploading code. Here we will need a robot car chassis kit. We will use Arduino Uno, install it first to our chassis kit. We will also use a 4DC motor, and let's install it in our chassis kit first. And to run servo motors and 4DC motors, we will use L293d motor driver module. It is suitable device to use for stepper motors, gear motors, and etc. The L293d motor driver module receives signal from the microprocessors, which is the Arduino Uno, and transmit the relative signals to the motors. The motor on the front left side is connected to M1, and on the rear left side is connected to M2 of the L293d motor driver module. If you haven't subscribed yet, subscribe now to Russell Electronics to keep you updated in our newly uploaded videos. The motor on the rear right side is connected to M4, and on the front right side is connected to M3 of L293d motor driver module. And to turn the head of this robot, we will use a servo motor. To calculate the distance, we will use HC-SR04 ultrasonic distance sensor module. Remember, before you place the ultrasonic distance sensor, you will make sure that the servo motor is at 0 degrees. The servo motor is connected to servo 2. The GND is black wire, echo is white, trigger is brown, and the VCC is red wire. The GND is connected to GND, and the VCC is connected to 5 volts. The echo pin is connected to pin A5, and the trigger pin is connected to pin A4. And before we proceed to programming, remove the PWR jumper. And now, let's proceed to downloading libraries and uploading code. Last time, we used Arduino IDE 2.0, but now, let's try to use Arduino 1.8. First, go to Tool, Manage Libraries, then search servo.h. Install the latest version of this library. After it is installed, search for Adafruit. Let's find it, the Adafruit. I already installed it, but let's install the latest version of that library. And this is the library that we need. Install the latest version of that library, and yeah, that's it. Close. Then let's upload the code. I include the link of the docs in the description below. Just visit it and copy the code. Then paste the code to our software and upload it. So easy. So easy. And it is compiling sketch and uploading, and then uploading. Disconnect the robot to our laptop, and to power the robot we will use an 8.2 volts 2S1P 18650 lithium battery. If you can see, we have also returned the PWR jumper.
Be cruising in my lane fast, call it high speed. I've been working hard, yeah, I've been working nightly. If you think you'll win, ha, not fucking likely. I be taking shots, yeah, cold